On the remote edge of the solar system, where the sun's light is but a faint glimmer like a distant star, lies a world once dismissed as a dead dwarf planet. Yet, when humanity first laid eyes on it, everyone was stunned. Pluto revealed itself not as an inert ball of ice, but as a vibrant world. Towering cryovolcanoes, a fragile blue sky on the verge of disappearing, bizarre methane dunes like a frozen desert, and even an ocean hidden deep within its eternal ice. And the wonders didn't stop there. Not far from Pluto is Arrokoth, a crimson-hued object shaped like a cosmic snowman, holding memories from the dawn of the solar system. These two alien worlds have not only shattered old preconceptions, but have also unveiled mysteries that could change our understanding of life beyond Earth. Pluto, from a dead dwarf planet to a living world. For decades, the image of Pluto in the human imagination was faint. It was often depicted as a small, dark, cold block of ice drifting at the edge of the solar system. Astronomers believed it was a place devoid of geological activity, with a virtually non-existent atmosphere and certainly nothing noteworthy beyond a surface covered in frozen nitrogen ice. It was labeled a dead dwarf planet, a desolate land that had seemingly been dormant for billions of years. However, all these notions were completely overturned in July 2015 when NASA's New Horizons probe flew past Pluto. In a few short hours, the small spacecraft sent back a stream of images and data that would change astronomical history. Instead of a lifeless ice ball, we saw a vibrant world with a diverse landscape. Majestic mountain ranges, vast stretches of ice, and traces of unexpected geological activity. What stunned scientists and the public most was Sputnik Planitia, a giant heart-shaped basin shining brightly on Pluto's surface. This heart spans thousands of kilometers, covered in a glistening layer of nitrogen and carbon monoxide ice that reflects the distant sunlight like a colossal mirror. From a forgotten dwarf planet, Pluto suddenly became the center of global attention. That heart symbol was more than just a geological feature. It was a declaration that this planet was still alive. The alternating light and dark regions surrounding the heart added to its mystery. Some areas featured massive, steep mountains, while others were flat plains that looked as if they had been recently leveled. This indicated that Pluto's surface was not static, but was continuously being renewed by internal geological processes. The more scientists observed, the more they realized this was not a dead world, but a small planet still brimming with energy. From a frozen graveyard, Pluto became proof that the universe holds many surprises. It sparked a profound thought. If signs of activity can exist in the coldest, most remote places, how many other worlds might be quietly breathing in the darkness, completely unknown to us? Giant cryovolcanoes. When the New Horizons spacecraft flew past Pluto, one of the most shocking discoveries was the presence of enormous mountains that resembled volcanoes. But unlike those on Earth, they didn't spew fiery lava. These were cryovolcanoes, erupting a frigid mixture of water, ammonia, and methane ice. The most prominent among them is Right Mons, towering over 4 kilometers high and nearly 150 kilometers wide. Alongside it are Picard Mons and Clark Mons, forming a massive complex with a volume comparable to the supervolcanoes in Hawaii. Their surfaces are rugged, marked with large pits and strange depressions, like a volcanic field sculpted from ice and snow. Even more surprising was their age. Observations showed a near absence of impact craters in the surrounding area, evidence that they are very young, only a few 100 million years old, perhaps even younger. Compared to the 4.5 billion year age of the solar system, this is merely the blink of an eye. This implies that Pluto may still be geologically active today. But how could such a small, cold world sustain the energy needed to fuel cryovolcanoes? Scientists have proposed several hypotheses. Heat from radioactive elements in its rocky core, the presence of ammonia acting as an antifreeze for water, or a layer of methane clathrate hydrate acting as an insulating blanket. Whatever the mechanism, this discovery has changed our perspective on Pluto. It is not a silent, dead dwarf planet, but a world with a smoldering inner life. These colossal ice volcanoes are like a cold heart, breathing slowly, raising a fascinating question. Even now, in the darkness at the edge of the solar system, could they be seeping flows of ice lava silently reshaping this distant world? The subsurface ocean, Pluto's hidden heart. As the first images from New Horizons were analyzed, scientists noticed vast networks of fractures and stretched terrain on Pluto's surface, as if the ice crust was being pushed and pulled from within. These features couldn't be explained by simple meteorite impacts. Instead, they pointed to a bold hypothesis. Beneath the thick ice shell, a liquid water ocean might exist. The idea seemed incredible at first. Pluto is too small and too far from the Sun, with surface temperatures hovering around -230 degrees Celsius, 382 degrees Fahrenheit. Under such extreme conditions, water should have frozen solid billions of years ago. Yet, special mechanisms appear to have kept this subsurface ocean from freezing. One study suggests that Pluto's ice shell could contain a layer of gas hydrates, methane trapped in ice, which is an excellent insulator. Like a giant blanket, this layer would slow down heat loss, keeping the water in a liquid state for billions of years. Furthermore, this ocean might contain salts and ammonia. These compounds act as a natural antifreeze, lowering the freezing point of water and helping it remain liquid even at temperatures far below 0 degrees C, 32 degrees F. This combination of an insulating layer and special chemical composition could have created the conditions for a subsurface ocean to persist to this day. Comparing Pluto to other worlds reveals interesting similarities and differences. Jupiter's moon Europa and Saturn's moon Enceladus are also thought to have subsurface oceans, heated by the immense gravitational pull of their giant parent planets. But Pluto is different. It exists alone at the edge of the solar system, with no external source of heat. Yet its ocean survives, a testament to the fact that even small worlds can retain their own vitality. And from this, a profound question arises. If Pluto's subsurface ocean truly exists, could it be a habitat for microbial life? An environment of salty, ammonia-rich water, shielded from cosmic radiation and the harsh surface, is not unlike the conditions that support life at the bottom of Earth's oceans, where microorganisms thrive around hydrothermal vents. We have no direct evidence yet. The New Horizons spacecraft only made a fleeting flyby, insufficient for detecting biosignatures. But the idea that an ocean is silently flowing beneath the ice at the far end of the solar system, and that tiny organisms could be living within that darkness, is enough to send a shiver down the spine. Perhaps Pluto's hidden heart is whispering a secret we have yet to uncover. The disappearing blue atmosphere. As New Horizons swept past Pluto, it revealed a sight that captivated the world. A delicate blue sky enveloping the dwarf planet in the faint twilight. A haze of nitrogen and methane scattered the weak sunlight, creating a magical aura, as if Pluto were cloaked in an enchanted veil. But this beautiful spectacle is slowly vanishing. From 1988 to 2016, astronomers observed that Pluto's atmospheric pressure had tripled. This was because, during the phase of its orbit closest to the Sun, the nitrogen and methane ice on its surface warmed up and sublimated into gas, inflating the atmosphere. This growth, however, was short-lived. After 2016, the trend reversed. The pressure plummeted, dropping by more than 20% in just a few years. If this rate continues, scientists predict that by around 2030, Pluto's atmosphere will have almost completely frozen and fallen back onto the surface as frost. The planet will become a stark ice ball with a clear but frigid sky, losing the mystical blue haze that once mesmerized humanity. But that won't be the end. Pluto's orbit is 248 years long. As it moves away from the Sun, its atmosphere collapses. But during its next cycle, as it swings back closer to the Sun, the ice will sublimate again, and the atmosphere will be reborn, swelling up as before. It's a cycle of death and rebirth, repeating like the slow breath of a hibernating creature. This makes us realize that even a tiny world at the edge of the solar system is not static. It breathes in and out on a rhythm that spans centuries. And as we watch that blue atmosphere slowly fade, we understand that even in its temporary death, Pluto holds a promise of rebirth. It just doesn't follow a human timescale, but the endless rhythm of the cosmos. Methane dunes, traces of wind on a distant world. In 2018, another surprising discovery shook the scientific community. Pluto has dunes. Yes, dune fields similar to those in the Sahara Desert on Earth. But here, the sand isn't quartz or rock dust, but frozen methane crystals. These dunes were found at the edge of the vast icy plain, Sputnik Planitia, where the massive nitrogen ice sheet meets towering mountains of water ice. Viewed from above, they form parallel rippling lines, as if a wind had once whispered across the surface, carving its signature into the frozen landscape. A major question immediately arose. How could wind be strong enough to form dunes in an atmosphere so thin it's only 1/100,000th that of Earth's? The answer lies in sublimation. When the faint sunlight strikes the surface, nitrogen ice turns directly into gas. As the nitrogen gas rises, it carries enough energy to lift tiny methane particles into the air. Gentle winds then gather these particles into dunes. The existence of these dunes allows Pluto to join an exclusive club in the solar system. On Mars, we've seen dunes made of carbon dioxide ice. On Titan, Saturn's moon, there are giant dunes of hydrocarbons. And now, at the very edge of the solar system, Pluto displays its own methane dunes. This scenery evokes a powerful image. Even in the coldest, seemingly static places, wind still finds a way, patiently breathing life into the landscape. The methane dunes are proof that even under the most extreme conditions, nature always finds a way to leave its mark. Arrokoth, the cosmic snowman. After completing its historic flyby of Pluto, the New Horizons spacecraft continued its journey deeper into the Kuiper Belt. On January 1, 2019, it encountered Arrokoth, an object never before seen up close by humanity. At first glance, Arrokoth looks like a cosmic snowman, two flattened spheres, one larger and one smaller, joined together in a peculiar shape. The entire object is about 35 kilometers, 22 miles, long, with a remarkably smooth surface and a deep red color, like a giant raspberry frozen in the cold void of space. The scarcity of impact craters indicates that it has been perfectly preserved since the dawn of the solar system. What makes Arrokoth so special is its pristine nature. Scientists call it a time capsule, preserving the very first materials that formed the planets 4.5 billion years ago. Unlike asteroids or comets that have been shattered, melted, and reformed, Arrokoth has remained largely untouched by violent events. It stands as a silent witness to the chaotic early days of our solar system. The formation of Arrokoth also reveals a fascinating story. Instead of a violent collision, its two original bodies likely orbited each other, spiraling together in a slow gravitational dance before gently merging. This gentle accretion is starkly different from the scenario of high-speed impacts. It suggests that, at least in some regions of the early solar nebula, planets and small bodies could have formed in a much more delicate manner than previously thought. Scientists emphasize that Arrokoth didn't form from chaotic collisions, but through a special process called pebble cloud collapse. In this scenario, a cloud of dust and ice particles in the primordial solar nebula gravitationally collapsed and gradually merged at very low velocities. This mechanism challenges the traditional model of collisional accretion and makes Arrokoth direct evidence of how the first building blocks of planets were born. But Arrokoth is more than just a strange shape. Its reddish hue comes from the presence of tholins, complex organic compounds that form when ultraviolet light and cosmic rays interact with simple gases like methane and ammonia. Tholins are not life, but they are considered precursors to it, the chemical building blocks that can lead to the formation of amino acids and other biological molecules. This has profound implications. Arrokoth may be direct evidence that the first building blocks of life were widespread in the early solar system. They didn't need Earth to appear. They were already present in the ice and dust drifting at its distant edge. Looking at Arrokoth, we see not just a cosmic snowman, but the story of how planets form and a clue to the origin of life itself. It's like a message sent from a time of chaos, whispering that sometimes life begins not with a bang, but with the gentle touch of stardust. Scientific significance and the question of life. The revelations from Pluto and Arrokoth have completely changed how we view the outer solar system. This region was once considered a frozen, static graveyard filled with ice-covered rocks. The reality is far different. It is a dynamic realm that preserves ancient history and is still active beneath its icy crust. On Pluto, evidence of a subsurface ocean suggests that even a small dwarf planet far from the Sun can maintain a warm heart. If this ocean contains salts and ammonia, it could create a stable chemical environment where microbial life might persist. The giant fractures and stretched terrain on its surface are reminders that, beneath its cold exterior, this planet is far from dead. Meanwhile, Arrokoth acts as a time capsule from 4.5 billion years ago. Its reddish surface is coated in tholins, complex organic compounds that could serve as the raw materials for early life. Tholins are not life, but they are the first bricks, the chemical building blocks that can lead to amino acids, the foundation of life. When we consider these two worlds together, a complete picture emerges: liquid water below and organic compounds above. These are the two core ingredients for life to sprout. If these conditions can exist at the edge of the solar system, a dark, cold place far from the sun's light, it raises a major question. Could life be far more common than we ever thought? Perhaps Earth is not an exception, but just one of countless worlds where the universe has sown the seeds of life. If so, every discovery about Pluto or Arrokoth is not just a scientific story, but a clue leading us to the answer to humanity's greatest question: are we alone in the universe? Future missions. The historic flyby of New Horizons was fleeting, just a few days of data on Pluto and a few hours past Arrokoth. Yet, that was enough to redefine everything we knew. And that brevity has fueled a new ambition: to go back, not just to fly by, but to stay and explore. NASA and other research groups have already sketched out ideas for a Pluto orbiter. This spacecraft would not leave quickly, but would circle the dwarf planet for years. It could map the surface in high resolution, monitor changes in the atmosphere, and even deploy a lander to analyze the ice on site. If successful, we would gain a comprehensive understanding of its structure, composition, and the subsurface ocean below. The challenges, however, are immense. To reach Pluto and then slow down enough to enter orbit would require a tremendous amount of energy. Scientists have proposed advanced solutions, such as nuclear-powered ion engines or using gravity assists from Pluto's large moon, Charon, to naturally brake the spacecraft. This isn't just about exploration, it's a testing ground for the space technologies of the future. The plans are even more ambitious. After completing its mission around Pluto, the orbiter could then depart to visit other objects in the Kuiper Belt. In doing so, it would become a long-term traveler, expanding on the legacy that New Horizons began. In the meantime, New Horizons itself has not stopped. It continues to send back data on cosmic dust, the solar wind, and interstellar space. The small craft is slowly approaching the final frontier of our solar system, where the endless darkness of interstellar space begins. Future missions, if they become a reality, will not only help us better understand Pluto and Arrokoth, but will also open the door to a new era, the age of exploring the most distant worlds. Pluto and Arrokoth have proven that the edge of the solar system is not a dead zone, but a vibrant treasure trove where past and present intertwine. A small dwarf planet holds an ocean within its ice, and a cosmic snowman holds secrets from the dawn of the universe. All of this reminds us that the most wondrous things sometimes lie in the most distant and unexpected places. As New Horizons continues to hurtle toward the infinite darkness, it carries with it humanity's hope to find not only life, but also ourselves in this vast cosmos. Because perhaps the answer to whether we are alone will not come from nearby, but from these distant worlds, whispering in the dark.